A warm welcome to all the viewers. Today's session of tourism and hospitality research is going to be a special session as I'm going to discuss with all of you what is PLSpredict and how to use it, when to use it, and how you can present the results in your research. So let us start. What is PLSpredict? Now, in my earlier video, I had explained to you what is Q square. That is the predictive relevance of the endogenous construct, the endogenous variable in your study. That is the dependent variable. And it is measured for those endogenous variables which have reflective indicators only. It is not meant for formative indicators, latent variable. But how PLSpredict is different from it? Q square is a measure of predictive relevance, indicating how well the model's predictions on a holdout sample compare to the actual values. Essentially, Q square tells if your model is good at predicting future outcomes, while PLSpredict helps you to understand the source of those predictions and compares them to a simpler approach, that is linear model. So I'm going to tell you how does PLSpredict compare the smart PLS model, the variance based model, with the linear model, the simple model, and it helps you to assess whether you can comfortably go ahead with PLS software for the analysis, or you should turn over to the linear modeling. PLSpredict is a method used in partial least square structural equation modeling to assess the predictive power of a model by comparing its predictive performance on a holdout sample against a benchmark. It helps us determine how well the model generalizes to new unseen data, which is out of sample data. Now, these are some of the useful resources which you can refer to by Shmuley et al. 2019, Shmuley et al. 2016, and Danks and Ray 2018. Now let us go to Smart PLS and see how practically we execute PLSpredict. So here we are in our PLS model, which we built up in the previous examples also. If you want to know what is Q square, how do we assess Q square, that is the predictive relevance of the endogenous, the dependent variable, then you might like to go back to the playlist and watch that video. Here we are particularly talking about PLSpredict. So again we have food quality, cultural authenticity, service quality, and value for money. 4 independent variables, each having 4 indicators, each indicator measured on a Likert 5-point scale, where 1 stands for strongly disagree and 5 stands for strongly agree. We have a dependent variable which is behavioral intention, which is being predicted by all these 4 independent variables. Again, BI has 4 indicators, each measured on Likert 5-point scale. Now, how to execute PLSpredict? You go to calculate and here you see PLSpredict. I click on PLSpredict. The number of folds is 10, number of repetitions is 10 by default. I do not need to change anything. If you want to read what are number of folds, what are number of repetitions, the description is mentioned over here. I just click on start calculation and I will get the results. So fast and so nicely assembled by Smart PLS. Now, you see here MV prediction summary. MV stands for manifest variables. Those are the observed variables or the indicators. So that is why you have BI1, BI2, BI3 and BI4. You have latent variable prediction summary, LV, and here you have root mean square error, RMSE, mean absolute error, MAE, and Q square predict. We generally don't use this MAPE, mean absolute percentage error. When I see the PLS MV prediction summary, manifest variables in my PLS model of the endogenous construct, that is behavioral intention, 4 indicators are there. I need to compare either the RMSE or the MAE with the linear models RMSE or MAE. Now, how to decide whether I should compare the RMSE or I should compare the MAE of PLS and linear model? For that purpose, I need to look into the normality of the residuals. So from where I can assess the normality of residuals? In case the residuals are normally distributed, then I will go in for comparison of root mean square error. In case the residuals are not normally distributed, I will go in for the comparison of mean absolute error. So let us see. I'll go to PLS MV error history. So this is how I'll check. This is BI1, BI2, BI4 and BI3. If it's a bell-shaped curve, then I would say yes, the residuals are normally distributed. I see a longer tail towards the right end, that means it is positively skewed. If I see BI2, again you see it is positively skewed. BI3, I can say positively skewed, and BI4 is negatively skewed. You can see that. Now let me check the linear models manifest variables error histogram. So for the linear model BI1, you see it's positively skewed. BI2, you see again positively skewed. The tail is longer towards the right side of the mean. So 0 is the mean and tail is longer, it's tapering towards the right side, that means it's positively skewed. BI3, again you see a longer tail towards the right side, and BI4, again there's a spread of data points on the right hand side. They are going up to the level of 3.25, you see here. So that means that the residuals are not normally distributed. In that case, I would be comparing the mean absolute error of PLS model and the linear model. How to do that? I just click here, copy to clipboard Excel format. So here we are in our Excel sheet, and I'll paste the data like this, and I'll mention over here this is for PLS model. Similarly, I'll do it for linear model. So for linear model, I just click Excel format and copy that thing as well, like this. Now I need to compare. I need to compare the mean absolute error of PLS and linear model because the residuals were not normally distributed. So I erase the column of RMSE, root mean square error. I delete it. And I also delete mean absolute percentage error. We are not going to use that. So this is how I deleted it. So I need to compare the mean absolute error of PLS model and my linear model. How to do that? So I'll simply type in the formula over here. You see B3 minus F3. So I'll write is equal to B3 minus F3. So I get the value minus 0.012. I'll just pull it down and all of these are minus. That means my PLS mean absolute error is lesser than what I see in linear model. So that indicates that my PLS model is better in predicting the results than the linear model. If I want to see the Q-square predict, which is the predictive relevance also, I see that in case of PLS modeling, the Q-square predict is higher. It has higher predictive relevance as compared to the linear model. So now I can easily write down and say that I am using PLS modeling for the analysis of my data because through PLSpredict I have assessed that PLS is better in predicting my results than the linear modeling. So I hope this was quite useful and interesting for you, and you will definitely share it with your friends and faculty colleagues. Thanks for watching. Keep learning and keep watching for more.